Hello friends, today we are going to discuss about squares and square roots. Side, multiply, side. This is the area of square in geometry. What is the side here? Side is length of square. Or in general, if a natural number m can be expressed as n square, where n is also a natural number. Here, m is a perfect square or square number. Now, let's have a look on the properties of squares and square roots. First one, perfect square always end with 0, 1, 4, 5, 6, 9. A number which ends with 0, 1, 4, 5, any of these number on its ones place, that can be a perfect square. What I say? Can be, right? If any number with these numbers will be a perfect square, it can be. But the number, those ends with 2, 3, 7, 8 at one's place, that will definitely not be a perfect square. You can imagine any number ends with 2, 3, 7 or 8. If we are going to make some number ends with 2, let's make 22. Start with that small number. Is there perfect square 22? No. You can try like 11 twos are 22, right? 1 22s are 22, but it's not a perfect square. For the perfect square, we need a natural number. Like here we tell you n is the natural number, and the natural number must be the product of itself. We have to need one natural number that we multiply with itself, and we got the 22, but there is no number like that, right? And the 3, 23 or 33, no, they are also not a perfect square. 7, let's have 47, no, it's also not a perfect square. Let's make some number ends with 0, 1, 4, 5, 6, 9, 100. See, is perfect square? Yes. 10 multiplied 10 is equal to 100. So the 100 is a perfect square for that. And 1 is like 121 is 11 multiply 11 is equal to 121. This is a perfect square. And note, I says like the number ends with 0, 1, 4, 5, 6, 9 can be up, not always, right? This is a second property. The number ends with 0, 1, 4, 5, 6, 9 may or may not be a perfect square. Let's make some number which are not perfect square but ends with 0, 1, 4, 5, 6, 9. Let's have a look. The number ends with 0, 10. So we can see like 1 into 10 is equal to 10. 10 is not a perfect square, but its digit at one's place is 0. Same, the number ends with 1, like 11, 21, 31. These are the numbers. They're ending with 1 on its one place, but they are not a perfect square, right? And the number 4, we can make 14, 24, 34, 44. Yeah, but see, 14, 24, 34, 44. These all are not a perfect square. And the 64, 8 multiply 8 is equal to 64. So the 64 is a perfect square. So we have to check like the number ends with 0, 1, 4, 5, 6, 9. They are perfect square or they are not. But the number ends with 2, 3, 7, 8. We can definitely say they are not a perfect square. And the next property, the number of 0 at the end of the square number is always even. Any number which ends with 0, we can check the number of zeros that must be even in the square number. In the square root, the number of 0 will be half than the square number. See, the square root of 10. Square number is 100. So the number of 0, there are 2 zeros. That's why the number of 0 is even, not the odd number. Number of 0, that can never be odd in square number. Same for 20 square is 400. See, there are also 2 zeros in the square number. In the square root, there is a 1 0. For the 30, same, 30 multiplied 30 is equal to 900. See, 2 zeros. Even we can apply it for like 100 square. What will be going? 100 multiply 100. We can see there are 4 zeros. There can never be 3 zeros, right? Then the number will not be a perfect square. So what's the conclusion for this property? The number of zeros at the end of square of number is twice the number of zeros at the end of the number. Next, square of an even number is always even. Try square of any even number, you will get an even number. We are going to try the square of 4, right? 4 into 4 is equal to 16. This is also an even number. And square of 8, 8 into 8, 64. That is also even number. 12 into 12 is 144. It's also an even number. The next one, square of an odd number is always odd, right? If you try to find the square of any odd number, that will also be odd. Try square of 1, 1 into 1, 1. Square of 3, 3 into 3, 9. And the square of 9, 9 into 9, 81. These all are odd numbers. Next one, if you watch just one digit of the square of a number, if we are going to look the last digit, the ones place digit of a square number, then we can find the last digit of the square root. If the number ends with 1 or 9, then the square must be end with 1, right? Try any number which ends with 1, like the number ends with 9 and 1. There are 9 and 11, right? And the square ends with 1 for both. For the 9 is 81, the one digit is 1, and for 11 there is also 121 which ends with 1. Last digit, one's digit is 1, right? Same for 2 and 8. The number ends at 2 or 8, right? What will be the square numbers? Last digit 4. Let's see. 12 square root 144, right? The number ends with 2. What is the square number? Ends with 4, right? The number ends with 8. See, for the only the 8 is 64. And for this one too, square number ends with 4. And the number ends with 3 or 7. The square number will be going to end with 9. And for 4 or 6, this will always 6. For 5, it will be always 5, right? Okay. Next property. There are two n natural number between the square of two consecutive numbers. If there are two consecutive numbers, if like 4 or 5, 2 or 3, 6 or 7, any number, they are going coming together, right? There are two n natural number between those numbers. Let's try to check it. Consider the number n as 4, and the next number will be n plus 1. One number after 4 is 5. What will be the square for the 4? Is the 16, and for the 5 is 25. Now see, we are going to prove like there are two n natural number between these two numbers. First, here n is 4, right? We say two n natural number. How many natural number? 2 multiply n. 2 multiply 4 is equal to 8. 8 natural number. Let's have a look. How many numbers lies between 16 to 25? 17, 18, 19, 20, 21, 22, 23, 24. Count. 1, 2, 3, 4, 5, 6, 7, 8. What we say? 8 natural number. Is it proved, right? Okay, next one. Square of a natural number n can be expressed as the sum of first n odd numbers, right? Any natural number. Square of any natural number can be expressed as sum of first n odd numbers. Same odd numbers. Have a look for the example, like square of 2 is equal to 4, right? Square of a number n. Here n is 2, right? Then first two odd numbers. First two odd number which are 1 plus 3 is equal to 4, right? And for 3, what is the square of 3? 9. And how many natural number? First n means 3. 1 plus 3 plus 5. See, 1 plus 3, 4 plus 5, 9, right? And same for 4. We can check what is the square of 4? 16, right? How many natural number we have to add? 4. First 4 natural number. We can't like take 1, 3, 7 or 9. We can't do like that. First 4. First 2. We have to count only first numbers. 1 plus 3 plus 5 plus 7. Okay. And the answer will be 16. For 5 square is 25. We have to add first 5 odd numbers. For 6 we have to add first 6 odd numbers. And the next one, the square of an odd number except 1 without 1. This property is not going on 1. Without 1, all the odd numbers, right, can be expressed as sum of two consecutive natural numbers. Square of 3 is equal to 9, right? Is there any two numbers? Yeah, there are two numbers. 4 plus 5 is equal to 9. What we say, like sum of two consecutive natural number, right? 4 plus 5. Same for 5. Try the next odd number, right? 5 square is 25. 12 plus 13 is equal to 25. Then how we can find the consecutive natural number for this one? There is a formula. If n is an odd number, right, then n square is equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. Two consecutive natural number you can find in this way, right? What will be like in case of 9? How we know what will be the two consecutive natural number? 9 square minus 1 divided by 2 plus 9 square plus 1 divided by 2. 9 nines are 81 minus 1 divided by 2 plus 9 nines are 81 plus 1 divided by 2. See, 81 minus 1, 80 divided by 2 plus 81 plus 1, 82 divided by 2. 80 divided by 2, 40 plus 82 divided by 2, 41. Okay, in this way we can find the consecutive natural number. Okay, next one. This is the formula for the product of two consecutive even or odd natural numbers, right? How we can find the product of two consecutive natural numbers? This is the formula for that. If n is the natural number, then n minus 1 and n plus 1 are two consecutive even or odd natural number, right? N is only a natural number. Then if we are going to find two even number or two odd number, then we have to do like this, right? This is the first even or odd number and this is the second one, right? And the formula, how we can find the product? N square minus 1. What will be the product? N minus 1 multiply, product is multiplication, right? n plus 1. If you try to solve this equation, you can find n square minus 1. If one try to expand this, n multiply n is n square, n multiply 1 plus n, or minus 1 multiply n minus 1 multiply plus 1 is equal to minus 1. N square plus n minus n. It's going to 0, right? Going to cancel each other, and again minus 1. What is going to left? N square minus 1. This is the formula to find a product of two consecutive even or natural numbers. Next one. The difference of two consecutive natural number is equal to the sum of both of the numbers. Okay, let's have an example. Two consecutive natural number, any one. Right here 5 and 4, right? 5 square minus 4 square. We are going to take the big one first and the small one after that. 5 square minus 4 square. Is it try to solve? 5 5s are 25 and 4 square, 4 4s are 16. 25 minus 16. What is the answer for this? 9. And what they say in this property, the difference of the square of two consecutive natural number is equal to the sum of both natural number, right? 5 plus 4 is equal to 9. But what is the condition for this one? The number must be consecutive, right? Okay, see the other example. 10 square minus 9 square. 10 tens are 100 minus 9 nines are 81, and we find 19, the difference. Now add these two numbers. 10 plus 9 is also 19. Okay, now we got a formula for that. We can say like here n is natural number, any natural number. First n plus 1 square minus n square. We are going to subtract small number from the bigger one, right? Is equal to n plus 1 plus n. Both number. We have to add these two numbers. We can find the difference in this way too. We don't need to solve. Sometimes the number is so big. Like if you try to solve like in this way, like 121 square minus 120 square, it's hard. Like you have to find the square root, right? You have to multiply them or find the other way. Like this will going to a big multiplication. In this way, it's easy. If you have just find the difference between the square root of these two consecutive natural number, you can just add them. 121 plus 120. You can find the difference between the square root, right? And the next one, the square of a negative integer is always positive. Any negative integer, you try to find the square, like minus 3, minus 5, minus 2, minus 7, anything. When we multiply minus with minus plus, minus 3 multiply minus 3, minus is going to cancel the other minus, and we got just 9, right? That's why if you try to find the square of negative integer, it will always be positive. Okay, next one property, the square of a proper fraction is always less than the given fraction. If you try to find the square of any fraction, right? Let's have an example. 2 by 3 square is equal to 4 by 9. This is the square for 2 by 3. See, 2 by 3 is greater than 4 by 9. If you try to find the its actual value in the decimals, for the 4 is 0.444, and for 2 by 3 is 0.666, right? And 0.666 is more than 0.444, right? For any proper fraction, if you try to find the square, that always be less than the given fraction. If this video is helpful, please like and subscribe my channel. Thank you.